Hi, my name is Cheng, and this is Mithun, and we are studying how various colors of urban greenery and man-made materials affect the surface temperature.
Now imagine this. You're walking outside barefoot. You walk on the tan sidewalk and your feet are just boning. You walk towards the green grass and your feet are cooling down. But the moment you step on the black asphalt, the road, you recoil in pain. The ground here just scolds your feet while the grass right beside us. Now why is this?
Now, this is due to the urban heat island effect, which is when a metropolitan area is a lot warmer than the surrounding areas. There are some factors that affect the UHI, including reduced vegetation, um, material properties, dark surfaces, urban geometry, etc. And colors can play a big role as they can minimize or maximize the UHI. Scientists can use satellites, infrared thermometers, and local weather stations to measure UHI.
Now, before conducting the study, we went through some literature, popular literature, and what we learned is that some of the things we learned is that one, vegetation can bring down air temperature using evapotranspiration, and trees color vegetation and can also bring down surface temperature while also providing shade. And for another source, we realized that the effectiveness of methods to reduce UHI effect with greenery can often depend on local characteristics and changes from area to area. And from another source we found a lot of background info that was crucial to learn about the albedo effect with the color of buildings with the UHI effect.
So some goals and questions we wanted to answer was how to determine how color of plants and buildings affect the UHI, and also create a scale to see which colors create the highest and lowest temperature. Some questions we wanted to answer included: how does local greenery affect the UHI compared to the color of buildings, and which colors for plants and buildings have the biggest impact?
Now, we had two hypotheses before starting. One of them being that darker shades of color, or on the light spectrum, have higher temperatures, such as black having darker is the higher temperatures it has, and overall that the red objects that are red will have the least heat, or the coldest, followed by orange, yellow, all the way to indigo and violet, being the warmest and attracting the most heat.
So the locations, for me, it was the Chicagoland area, specifically around my house and Peck Farm Park.
And for me in New Jersey, it was based in Atlantic County with the EHG PAL building.
So for our methodology, we wanted to compare and contrast the surface temperatures in our areas. We collected the data for a week, and then we also obviously used knowledge from Globe, and then we split them into two distinct groups, and then we graphed them to determine the effects. And then this is our data collection timeline. So for data processing, we basically just graph our data on a spreadsheet, and the data included minimums, averages, and maximums.
This is the open grid that we researched. The one side being Chicago, one side being New Jersey.
And then these are the man-made materials.
Now, one of the false correlations that we found was in going with hypothesis. The darker the pigment is and the color is, the more heat that the surface has. As for both New Jersey and Illinois, for both our areas, the darker the pigment of the plant, the higher surface temperatures this is, and often this correlates with the amount of light that's reflecting off. Just like how with a darker shirt, it'll be more than a whiter shirt in the sun. Same thing effect happens here.
For urban greenery, for Illinois, the colors yellow and orange had the highest surface temperature, but all of them were lower than the dark green shade. And for New Jersey, pink and green had similar temperatures, but green was still warmer, and this is due to like pink being the mix of red and purple.
Now, for man-made materials, while color does play effect in UHI, as seen here, it's not the only effect. As looking at New Jersey, theoretically, the light gray concrete should be cooler than gray mulch and black or matte, as light gray being lighter than the other colors, but this is not the case. And just like in Illinois, theoretically the blackwood should be darker, but in actuality, blackwoods are slightly lower in temperature than the gray slider.
And then in conclusion, for urban greenery, our scale from warmest to lowest starts from green to yellow/pink to orange to purple.
And the hierarchy in man-made materials went from black to gray to beige to white.
But overall, our findings showed that man-made materials have a higher surface temperature than all urban greenery.
Now, just like any study, that we had just some limitations. Some limitations of the textures of the materials, the geography of a study, the weather conditions as a study, time/budget, and the controlled environment.
Now, some next steps for us and for other people could include focusing on only urban greenery and the extent color plays within the same species, looking at how the tone of the color affects the UHI, and then looking over a larger time period and a larger range of species, and then looking at how the extent of materials and textures play a role.
Now, reflecting back on our experiences, on experience with the NASA Seas and this program, my best memory was at work, at EHE PAL, collecting research while on the job, and lots of my students/kids like coming up to me, watching me conduct research, them asking questions, them wanting to actually participate in the research and use the thermal thermometer. It was just like bringing kids into science and seeing how they loved it as much as I did.
And for me, it was just having a reason to be active and also collecting data for the first time. Thank you.
And these are references, and thank you.